Welcome. My name is Israel Gross, and I'm a Principal Solutions Advisor at Rocket Software. Today, I want to demonstrate how to detect and remediate wait problems in the world of CICS. So what is a wait problem? A wait problem is when a particular transaction seems to be waiting for an excessive period of time. It could be a single transaction, it could be multiple transactions, it could be the entire system where all the transactions appear to be suspended and no new work is able to start because the system is at max task. Now, if you're familiar with CICS, of course, you know most transactions are supposed to run sub-second. So anything that seems to be taking well above that would be a transaction that is waiting for some reason. And what we want to be able to do is detect and remediate the problem. But before we begin, let me just show you what my environment looks like, right? So I have a terminal owning region, also used for routing logic, and it dynamically routes workload between two different AORs, A1 and AR. So I never really know where the workload's going to go. And then if it needs to access DB2, it'll ship a request to the DR region. If it needs to access vSAM, it'll ship a request to the FR region. If it needs to access IMS, or if I'm using distributed program link, I'll see transactions running in IR. So in my environment, when you actually look at one transaction that's waiting, it can actually be attached to multiple different transactions, and therefore it can appear a lot worse than it might actually be. And I'm going to demonstrate that as well. But first, let me show you the response time structure of a CICS transaction. As you can see, a CICS transaction is either running or waiting. If you look at the IBM documentation, he will tell you that a transaction could be running, it could be suspended or waiting, or it could be dispatchable, which means it is actually ready to run, but for whatever reason, it hasn't been given access to the CPU yet. And you could see that if you're waiting for first dispatch or you're on a dispatch wait, which means that maybe I issued a file control request, and then next thing I know, the file control request completes, but the QRTCB, or the TCB I'm waiting for, is busy with another task, and so I have to wait in line to get access to that particular TCB. So I've set up a sample wait problem here, and I'm going to go into OMEGAMON for CICS. So here in OMEGAMON for CICS, you can easily see I have about 8,000 or 9,000 transactions running per minute. So I have a fairly busy system, not extremely busy, but busy enough. And the first thing I want to do is I want to take a look across the CICSplex I'm working with. If you remember, my regions all started with FUW. I want to take a look at my CICS regions and have a feel for what's running across them. The easiest way to do that is, again, you can use a slash if you need help with anything, but I'm going to use F for find, and then you'll notice there's several resource types I can find. If I pull the down arrow, it'll show me all the different resources, but I'm quite happy to see all the active tasks, so I'm just going to put an asterisk here and say find all the active tasks within my CICSplex running right now. Now, if I hit enter, you'll see this list tends to change as transactions start and complete. But what you'll also notice is at the top of this, you can see some transactions associated with OMEGAMON that have been delayed for 1 day and 23 hours. So I'm not really interested in those. I'm going to hide those transactions from showing up. To do that, I'm going to hit PF4. And what I'm going to do is select option 4 for elapsed time. And I'm going to say only show me transactions less than or equal to 3,600 seconds, which should only show me transactions that have been running for an hour. Now, I do not expect any transactions running for an hour unless they're batch transactions like the OMEGAMON ones. In a future version of OMEGAMON, there'll be the ability to exclude batch transactions from your system. Now, as I hit enter in this system, you'll notice that these transactions here at the top don't seem to complete. Every so often, a transaction or two will pop into my environment as they run. There's one. And you can see some of these show up as elapsed time as 0.01, which is a very short period of time. And then I have a bunch of these that appear to be waiting over 9 minutes. Now, this particular display is only showing me columns 3 through 13. I'd have to hit PF11, which I'm going to do in a second, to see the state of the task. But notice I can see the wait type, and I can see several wait types. There's a socket wait type. Here's one waiting for CPU in DB2. I can see a couple of NQ waits, and then I can see this interval IC wait here. So I know some of the transactions are waiting. I'm going to hit PF11. It'll show me one running transaction. So this guy was actually running. The rest of these transactions are suspended, which would imply that they're waiting for something. So I'm just going to hit PF10 and go back and show you that transactions are always cycling through. The way this is structured right this minute is that you can see the ones that are waiting for a shorter period of time appear at the bottom, right? So you can see it's sorted. And what I can do is I can actually sort this list by elapsed time. And so now you can see that the longest waiters are at the top and the shortest waiters at the bottom. I'm going to reverse that. So you can easily see I have a bunch of transactions, and the oldest transaction is DELY running in a region called FUWFWA1, which is again one of my AORs. Now, what I can easily do is do all the analysis from here. I could select this transaction. It'll give me the details for that transaction, an overview, and we can easily see that this is inside of a program called delay prog, get the idea, and it's in middle of an exec CICS delay, and that's not unusual if you issue a delay. What's unusual is that this delay seems to be for an excessive period of time. It'll also show me other tasks in the CICS with the same unit of work. And you can see another DELY transaction coming out of the TOR, and you can see a mirror transaction, CSMI, coming out of the FOR, which tells me that I typed in DELY in the TOR. It got routed to the AOR. I'm looking at the AOR transaction right now, and that required some file access off to an FOR, the FR region, and that was handled by a mirror transaction. So this appears to be my oldest task. I can click the Programs tab, and it'll actually show me DELY prog, and you can see the elapsed time now is up to 12 minutes just inside of that program. Now, normally you don't have this amount of time to do the analysis while there are people hanging up, especially if the entire system is hanging up. So what I would have done if this were a production environment is I'll hit PF3, I'll put a slash here, and it gives me various options. I can purge the task, I can force purge the task, right? Or I can kill the task. So I'm likely to want to purge the task, but I want to show you one other thing. Since I know that this delay is associated with somebody actually issuing file control requests, I can hit PF3, I can go back out to my CICS, I can hit enter over here, I can go down to my FOR region, which is the FR region, and I'm going to do B for a bottleneck display. And since I know there's some sort of an NQ argument issue, I'm going to type in E for NQs. Now, this shows me FCDS Rec D is actually the NQ pool I'm NQ'd on, and I have two waiters. And that kind of makes sense, even though it looked like I had about 9 or so tasks. But at this point, you figured out that I start 3 or so tasks in the TOR, and then I get all these alternate tasks as they route to different regions, and they're all connected to one another. If I actually go down to this one, local, I can see who's the owner. It's this mirror, 89512, and I can see these other CSMIs waiting what appears to be for the same exact record. So I can do further analysis if I truly have the time for it, but generally I don't. So let's go back to our CICS display, do a F for find, put in the asterisk, and we can easily see, if we again sort it by elapsed time, that the delay at the bottom seems to be the worst one. And again, if I wanted to see the task number associated with the person who locked the physical record, if you remember the task number from before, we can shift over to the right and see that. But since we've been waiting quite a bit of time, let's go in and remediate the problem. So I'm going to go down to the lowest one. Usually you kill the oldest one, and if that doesn't help, you kill the next one up. And that's just a standard a lot of people have used. So I'm going to put a slash there, and I'm going to try a purge. You'll notice that the purge failed because it's purge deferred. It's in the middle of an IO. So I'm going to do a force purge. And he says, are you sure? And I say, yes. And then I hit PF3 and I hit enter. And sure enough, all the tasks have gone away. Now you're going to say to yourself, but wait a minute, if I didn't have time to take a look at this problem while it was occurring, then purging it means that I can't do any further analysis on it. And then I would argue, well, no, not really. You can actually do some further analysis on it. What I'm going to show you is I can go to the CICS, I can type in an O, and if you have task history enabled, you can take a look at the transactions in the history itself. And so I can see these transactions which were suspended all around the same time, and I can actually tell these are all around 14 minutes. So I know already about the delay transaction, but if I wanted to do further analysis on it, I could select it. And here the difference is, instead of seeing a nice panel at the bottom that kind of shows you the related transactions, you have to click on the tab at the top. And the tab at the top will show you all related transactions. So I'm actually looking at the transaction starting in the TOR. I can see the FR mirror over here. I can see the delay command over there in FA1. If I click on FA1 and I go look at the programs, I can see that this spent the longest period of time, right, in the delay program. But I didn't look at the other transactions, so let's have a look at those. So there's the pay transaction and there's a data transaction that both originated from the TOR. So I'm going to start with the pay transaction, and what I'm really looking for is to see what program it might have spent most of its time in, because part of remediating this is to figure out the program that issued the command that caused this to be delayed. So you can see right here that when I look at it through the TOR, I can see the FR, the mirror that does the read. I can see A1 where it ran the tran ID pay. If I click on A1 and I look at the programs, I can easily see pay Pugum isn't at fault. You can see the elapsed time was very short. But if you look at pay bus, that's the program I'm going to want to look at. He was locked for 14 minutes. So something pay bus did, and we already know it, he tried to read for update probably the same record that delay program did, was delayed for 14 minutes and 58 seconds. I can also go back and take a look at the data transaction. And when I look at the data transaction and I look at related, you'll see that this transaction actually involved additional transactions. So it wasn't just the data transaction I ran in the TOR, which we're looking at. It caused the start of a transaction in the AR and A1 region. It also went to FR and IR. So that's why you saw 9 or 10 transactions waiting at this point. Now, I'm assuming it was in A1 where I had the issues, so we're going to take a look at the programs running in A1, and there you see data Pugum, and you can see 14 minutes. But let's just check the AR and see what he did. So if we go into AR, we can see he was just a mirror. So mirror transactions usually end up being not necessarily the culprit, but we'll take a look. That goes through an IBM program, so we can see the details of that. And so chances are it was held up by one of the other tasks. We can also take a look at the IR program. Now in IR, we actually did a DPL request, a function ship request, and that ran data bus, the business logic, and there you see data bus was hanging for 14 minutes and 49 seconds. So if you understand the way the application is structured, data Pugum gives control, the program gives control to the business logic. It was something within the business logic program that held up the transaction. Now, how would you remediate this problem on a more permanent basis? You certainly don't want transactions being held up for 14 or 15 minutes. So you have a couple of options here. One is an IBM option. On the transaction definition itself, you could code a D timeout, a deadlock timeout. As long as you mark it spurge equal yes, and you code a D timeout of, let's say, 2 minutes, then the transaction would have been abandoned by CICS after 2 minutes. which would have worked out for you. I don't tend to overuse D timeout because if you do, then what ends up happening is these problems can get worse and worse without you having any idea that they occurred. There's also another way to try and fix this problem using OMEGAMON. So if we go into individual CICS region and we assume that it's somewhere within my AORs, I can type in C for CICS control functions, and you'll see that under CICS control functions, I have an R for resource limiting information. If I type in R, what it'll allow me to do is set up resource limiting details for individual transactions. I could limit not just on elapsed time, but on things like CPU time, DB2, DSA usage. But obviously in my case, I'd probably want to do it on elapsed time. Now I could set the tran IDs, pay, data, DELY, and I can set a warn limit in seconds and a kill limit in seconds. And the warn limit would put out a message by default to message user, so you'd see that there was a warning, and if he had to kill the transaction, instead of seeing the ATCH append, you would see an RLEL append, which indicates that OMEGAMON was forced to kill this transaction because it exceeded its limit based on the resource that you decided to limit. So that's a little bit about how to detect, remediate, and even analyze weight problems in the world of CICS. I want to show you some reading material where you can further find information out on troubleshooting within CICS, not just weight problems. But first of all, the problem determination manual was renamed the troubleshooting manual, and here's a link for the manual in version 6.1. This is also linked to the performance weights, so you can actually read more about how to go about looking at performance weights and what you can do about it. Interestingly enough, you'll notice it starts out with inquire task list. I just did it at the CICSplex level, but you can do it at individual region levels as well. And you're looking for tasks that are suspended. Again, if you're ready to run or running, and again in CEMT, it'll show you as dispatchable, not ready, but nonetheless, you would see that same information. And then this is a list to all the suspend resource weights and types. If you remember back in OMEGAMON, when I actually pulled up the resources that were hanging, and let's see if we can catch a transaction and I can show it to you. If you get a suspended transaction, right, there's a suspend resource type and a suspend resource name, NQGenA, IR link, and there's the IR link. So this link will show you how or what each of the different types that IBM provide, what they actually mean, and what you can look out for to try and remediate those issues if they occur. Thank you for watching.